6.2 Properties of Parallelograms. All right, we're starting at numbers 20 through 25 all have the same diagram. And so we have the parallelogram ABCD. So this is for 20 through 25. They have the diagonals going through. So if they draw the whole arc like this where it's all connected and they give you a value, that means it's for the whole thing, not just for part of it. So just be aware of that. That's not saying that those two angles are congruent. It's just giving you the value of that whole angle. All right, so that's your given information there, and then they're asking us to find different measures from our parallelogram. So number 20, they want us to find DE. And they want us to basically say why as well.
Isn't it 10?
What?
It is not 10.
It is 10.
Because BE is 10.
Yep, so since BE is 10, then DE also has to be that. And so the reason would be that the diagonal of a parallelogram bisects, essentially, I'm just kind of shortening it. So BE equals DE, and obviously we already found the value. So you need to state the value that it is and then explain the reason behind it. 22 BC. So I have AD is 12. So what is BC?
12.
It is also 12. And that's because opposite sides of a parallelogram are congruent. So that means that BC is equal to AD. Or is congruent to AD, I guess I should technically say. Um, 24. This one's an angle measure. They want the measure of angle ABC. So, they want this angle right here. So any ideas what I might have to do to find this one?
Just be 11 and
360 minus 120 minus 120 to find what it could be.
Okay, so we know that angle A, I'm just going to say the whole angle, ignore the diagonals. The whole angle A is 120 degrees. So what does that mean about angle C?
120 degrees.
Okay, so angle A is equal to 120 and angle C is also 120. What do I know about the total degrees inside of?
360.
Yep, it's 360. So I'm going to do 360 minus 120 minus 120. So that's minus in total 240. So that would give me 120 is left over. We know that these angles are congruent. these angles also have to be congruent, so what would I need to do with this 120?
Divided by 2.
Yep, so 120 divided by 2 is 60, so that means the measure of angle ABC is equal to 60 degrees. Any questions on that before we move to the next thing? Okay. 26. These ones say to find the value of each variable in the parallelogram. So what is x equal to? 14. What is y equal to? Alright, so obviously that one's pretty easy. A lot of them, they are going to make you solve something out, but these are just basically having you apply theorems to solve for them. 28. Have another parallelogram with diagonals this time. And then this one is 3.5, this one is 6, this is R, and this is S. So, on these diagonals, what is R? Yep, R is equal to 6, S is equal to 3.5. 30. Another parallelogram. So this one we have, this angle is 70 degrees, this one is 2m, and this one is n. So how am I going to go about solving for m? Okay, so I'm going to set 2m equal to 70 because those are congruent. Opposite angles are congruent. Then divide by 2, so m is equal to?
35.
Yep, 35. Now, with the information that I've been given, how would I go about finding n?
360 minus 70 minus 70.
There's an easier way. You have another theorem for this. What's true about these two angles right here? They're supplementary, so what does that mean? They equal 180, so that means that n plus 70 equals 180. So n equals 110. So, Jonathan, the way that you said would work, but then you'd have to divide that by 2. So it's just more involved than just using this theorem. Alright, so those ones relatively easy. We're going to get into some that are a little bit more complicated, but still nothing too crazy. We've got another parallelogram. It's going to be the trend in this section. This side is 9, this one's 8, this one is 3y, and this one is 2x plus 4. So if I want to solve for x, how am I going to set that equation up?
2x plus 4 is equal to 8.
Yep, opposite sides are congruent, so 2x plus 4 equals 8. Subtract 4, so 2x equals 4. Divide by 2, x equals 2. And then how about solving for y? How do I set that one up? 3y equals 9, divide by 3, y equals 3. $36. It's a little more like a diamond. These values are going to be a little harder for me to write inside, so I'm going to draw little arrows to them on some of them. So this one is 2f minus 5. This one is g. This one is f plus 2. And that one here is 5f minus 17. All right, so as far as solving, I've got obviously two different variables. Which diagonal should I solve first? Should I solve the one going up and down or the one going side to side?
Up and down.
Up and down, why?
It's impossible to solve something like that with this one.
Yeah, I can't solve the one going sideways because I have two unknown variables and I have no idea what the whole thing is equal to. So I have to solve the other one first. So using the formula, we have 2f minus 5 equals 5f minus 17. I guess I should say theorem, not formula. But the diagonals bisect, so that means that those two things are equal to each other. So how would I solve this? We haven't done one with two variables in a while, I don't feel like.
Minus 17 minus 5 is equal to 150.
These aren't angles, these are side lengths, so I can't do that.
Add 5 and 7, or 2 and 5, and then add 5 and 7.
I can't add 2 and 5, but,
2f.
well, I know that, but I still am not adding.
You subtract.
To move it, I have to subtract. So if I'm going to subtract 2f
And then add 17.
and add 17, I'm going to do this all in one step. So over here, f's are gone. 17 minus 5 is 12 equals 5f minus 2f is 3f. Negative 17 and positive 17 are gone. Now I can divide by 3. So f equals 4. So now I can use this to solve for the other one. So I'm going to plug in 4 for f. So I've got 4 plus 2 equals g. So 6 equals g. All right, any questions on those? Pretty easy. All right, we're going to look at a few proofs then. Jumping to number 56. It's a big jump. So the given
Holy fuck.
is that PQRS and TUVS are parallelograms. I'm just going to use the symbol. I don't feel like writing the whole word out. Prove that angle 1 is congruent to angle 3. So the parallelogram, the picture that they give us, looks something like this. And then they give us inside of here, this is 1, this is 2, and this is 3. So this one obviously is a parallelogram inside of another one, so it'll be a little different than the one that we had in the PowerPoint. So statements and reasons.
Yeah, there's a daring to snap a jump.
This one isn't a long proof, so that's nice. All right, so what's always my first step? The given information. So PQRS and TUVS are parallelograms, and that is the given. So based on the picture, what do I know to be true with my theorems and stuff that I'm aware of for parallelograms?
Angle
Angle 1 is congruent to angle 2, and what else?
Angle 2 is congruent to angle 3.
Yep, angle 2 is congruent to angle 3. And that's because opposite angles of a parallelogram are congruent. Because you have your theorem and postulate book, I'm just going to write that out. That's theorem 6.3. If you want to write out in words, that's fine, but this is a shortened version of it. So then, with that information, if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, I can say angle 1 is congruent to angle 3 by what? Transitive property. And that's it. A little easier, right? Questions on that one? Alright, I told you we were going to have two parallelograms inside of a parallelogram, so we're going to do that one now. 58 given A, B, C, D, E, B, G, F, and then H, J, K, D are parallelograms. Prove angle 2 is congruent to angle 3. That's my big parallelogram. And then we have one in the top right corner and one in the bottom left corner, not touching each other. So again, all that would be given information to you. I'll let you write that down for a second.
So say I just got straight to the point in a proof, would you still give me the points?
Well,
I as soon as
as long as you have all the information you have to have.
that's what I'm saying. Like you know how the last one it was a proof angle 1 is congruent to angle 3.
But you can't just say that. You have to have the middle steps.
Oh.
Now, some things you can combine. Like I technically made the second step two different things, but they had the same reason, so that's why I combined them. So like that's fine. All right, statements, reasons. All right, what's the first step? Givens. A, B, C, D, E, B, G, F, H, J, K, D are parallelograms. So I know ultimately I'm trying to prove that angle 2 is congruent to angle 3, so that's here and here. So based on the information from the picture, what do I know to be true, or what can I say is true or congruent? All right, slow down, slow down. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Those are the only two things that have the same reason at the moment. Angle 1 is congruent to angle 4. So, that is all because of theorem 6.3, or you could say opposite angles of a parallelogram are congruent if you wanted to write it out.
Are you going to accept that on the quiz or test?
The number? Yeah, because you'll have your theorem and postulate book. So, I have this is congruent to this, I have this is congruent to this, and this one is congruent to this one. So what else can I now say? Angle 2 is congruent to angle 4 by what? Yep, transitive property. And then ultimately what?
Angle 3 is
Oh, I just wrote a 5 there. Angle 2 is congruent to angle 3 by, yep, transitive property. So in step 2, okay, obviously we put everything that follows theorem 6.3 together. You could have them all together. You could write them separate. I actually had 1 and 2 and then 1 and 4 in one step together when I did it earlier. And then I did 3 and 4 in its own step. I don't know why I did that, but anyways. So just be aware of that. The only thing is down here, when you're getting to what you want to prove, don't put these two things in the same step when this is what you're trying to prove. Do that as like its own step. That whatever you're trying to prove should always be your final thing, even if it has like the exact same reason. Okay. Questions on that? Pretty easy. Cool. So then problems. 21 through 37 odd. And I will not make you copy the pictures again on these ones. The only ones you really should copy the pictures on are the 2 proof ones that I'm giving you. And then 55 and 57. And just a heads up, after section 6.3, we'll most likely be having a quiz. So